Okay, Kashmon, you have an interview in ISRO uh, as the scientist slash engineering post in structural engineering. So first of all, tell me how we analyze this indeterminate structure. What are the methods to analyze the indeterminate structures?
But mainly there are two types of method. The first one is force method, and the second one is displacement method. So if the degree of static indeterminacy is less than degree of kinetic indeterminacy, then we go for force method. And the kinetic indeterminacy is less than static indeterminacy, then we go for displacement method.
What are the examples of the force methods?
Force method, the key methods are method of persistent deformation, linear throwing, and column analogy method, flexibility matrix method. And for
कौन सी
displacement,
फ्लेक्सिबिलिटी स्टिफनेस?
flexibility matrix method.
तुम्हारी आवाज ना साफ नहीं आ रही है, थोड़ा लाउड बोलो, थोड़ा सा, ताकि मुझे समझाए तुम क्या बोल रहे
Sir, I repeat, sir. For force
हो भैया.
method, the main methods are flexibility method, method of persistent deformation, column analogy method, flexibility matrix method, and for displacement method, the key methods are slope deflection method, moment distribution method, Tani method, and stiffness matrix method.
ठीक. Okay. We know that when we analyze the indeterminate structures, it is very easy for us to analyze the determinate structure as compared to indeterminate structures. Although we can analyze the indeterminate structure, but they are the little bit difficulty level as compared to determinate structures. But in structure, we mostly construct indeterminate structure. What is the reason?
The main reason for considering indeterminate structure is that uh, since that structure has multiple load paths, so even if one member fails, the structure will the entire structure will not fail because some other member will take that stress or the load, and the entire uh, load transfer process will happen from some other path. That's why we keep some extra member in order to have some factor of safety against structure failure.
Right. And how will you determine the permissible stresses in the structure, in the member, in any structural member? How will you come to know that these are the permissible stresses?
So if the structure is complex, then we have to make a model of it, or we have to simulate it in any software, and then by imposing the same loading and boundary conditions, we can find out the stress. If it is a simple structure, we can do it manually also.
And is there any formula to find these permissible stresses?
It depends on the type of loading. Like we are whether we want to find due to bending, here, whether it is a truss or a frame. So the formula will depend on the type of the structure and type of loading.
Let us suppose you have a truss. Then how we determine the permissible stresses in trusses?
Sir, we have to find the reactions, and then we have to find the member forces. So once we know the member forces, we can find the stress which is there in the member by dividing it with the area. Sorry, yes, member force divided by area will give the stress, and this should be less than the permissible limit of that particular section.
That I want to know exactly, but how will you come to know permissible limit?
The
How
permissible
will you
limit,
come to know how we find the permissible limit?
the permissible limits will be governed by two factors, mainly the yield stress and the deflection criteria. Whichever is minimum, we will take out of them, and the
How
stress
will
should
you?
be less than that limit.
Okay. One is the ductile, one is the yield criteria you have said, and second one is
Deflection criteria.
deflection criteria. What about the fracture criteria?
Sir, in truss, we don't design for fracture. because there is no bending moment in any member.
Okay, point you noted. But suppose that if you have a frame, there is a bending moment in the member. Suppose that you have a frame structure, so there is a bending moment in the member. Should you go for the fracture criteria or not?
Of course, for frame, the main criteria is bending only. So in that case, the flexure will be the governing one. And
So that means you want to say if we have a member, if that member is subjected to bending, in that case, we go for fracture criteria in calculation, yeah, for the calculation of the permissible stresses. You want to say like this?
yes, because even if we check the other criteria, it will be safe in all other criteria. So the main criteria
Okay.
will be here only.
Okay. Right. Okay, let me correct you little bit. Let me correct you little bit. Because when we talk about the permissible stresses, so permissible stresses we calculate by applying some factor of safety and the failure stress. That failure stress may be yield stress or failure stress may be a fracture stress or you can ultimate stress, not fracture point, it's ultimate stress. That depends on the material. If you have a ductile material, then the yield criteria will be the priority, yield criteria will be taken. If the material is the brittle material, then ultimate point you will take. So you calculate the permissible stresses by dividing the yield stress or by dividing the factor of safety with the yield stress. The yield stress by factor of safety will give you the permissible stress if you have a ductile material. But if we have a brittle material, then ultimate stress divided by factor of safety that will give you the permissible stresses for the brittle material. Basically, it depends on the type of material which you have. ठीक है? Okay. Uh, suppose that you have constructed one structure and we have constructed a truss structure, right? On the site, we have a truss structure. And when we analyze the truss, so we assume that every load acts on a joint. But in reality, we see load not only act at a joint, it also acts on the member also.
Yes,
So
sir.
these 2 points, we are analyzing the structure by considering, by assuming the load acts on a joint also. But in real, we see that truss members carries the load at any section of the member. So how would you justify this point? Are you getting my question?
Yes, sir. Sir, in general, uh, the loading that is applied at joints only. But there are external loads like wind load or even snow load, which can come on the member.
You are not
Exactly.
getting. Yeah.
Yes. I am putting a guess that the moment which would be caused due to the loading on the span would be very less, and hence it will be taken care of automatically.
Yeah. This is the answer. That if any movement comes out on a member, that magnitude is very, very less. We design our structure in that way also. Okay. What is the significance of the what is the significance of the kinematic indeterminacy of the structure?
Kinematic indeterminacy, it let you know the degree of freedom which are there in the structure. So if we know the decay of a structure, we can figure out how much degree of freedom, how many degree of freedom are there, what are the unknowns, and what are the restraints.
Restraints in what manner? Or you can say
Means
restraints in what sense?
means the degree of freedom which are constant. I mean, which are zero at joints. And what are at joints? I want to say.
Suppose that you have analyzed one structure, you have found decay kinematic indeterminacy of a structure, and you go decay of the structure is 3. What the significance of this key value here?
It means there are three degrees of freedoms which are unknown and which can be displacements or rotations.
Okay. How would you analyze this structure if you come to know that this structure has a decay 3?
So if decay is 3, then we can use any method like slope deflection method. In that, if decay is 3, then we have to write uh, three equilibrium equations. So out of them, two might be joint equilibrium and one can be shear equation,
Along with the
depending on the decay.
that these equations which are going to solve you or you going to use, that is extra than the equilibrium equation, or these are including the equilibrium equation? That means my question is this: if the structure decay comes out to be 3, so you are only using 3 equations that you told me, two joint equilibrium equation, one shear equation, or along with the equilibrium equation you are going to use these 3 equations also?
So sir, these three are equilibrium equation only.
That means
But we
only
will
three
write the
equations are sufficient. That means only three
uh,
equations are sufficient.
slope deflection equations for the joints, and then after that we will just use these three equilibrium equations to get the unknown displacements.
Okay, let me correct you a little bit. If any structure has a decay 3, it means we can analyze the structure if we know the minimum 3 unknowns. If we have found minimum 3 unknowns using the extra equations other than the equilibrium equations, and that extra equations, as you told me, joint equilibrium equation or shear equation. Using these equations, we can find these unknowns, and if we know the unknowns, now we can analyze the structure using the equilibrium equations. We have equilibrium equations 3: sigma fx equal to 0, sigma y equal to 0, sigma mz equal to 0. These 3 equations were required. These 3 equations were required. But if the structure has a decay value 3, it means given structure cannot be analyzed only using equilibrium structures. Along with equilibrium equations, we also have to find these 3 unknowns first. And these 3 unknowns are found by using joint equilibrium equation or shear equation. Getting my point?
Sir, I have a doubt that the joint equilibrium and shear equation, these are only called as equilibrium equation for this
Yeah,
method for slope deflection.
yeah,
And then
yes, these are the equilibrium equations.
the
No doubt.
solution.
Listen, Akashmon, these are the equilibrium equation. Let us suppose I'm giving you just simple structure. Let us suppose you have a proud cantilever beam, right? Proud cantilever beam, one end is fixed, other end is a roller support. Let us suppose, or not roller support, take a hinge point. That will be very easy. If we are taking a hinge point, or you can say roller support, and there's a vertical load act on the proud cantilever beam, so the decay of that structure comes out to be one only. Yes,
Yes, sir.
and that one will be the on the roller end or hinge end. That will be the theta here.
Yes.
Yes. If now for analyzing this probe cantilever beam, you have only one decay. So you will use shear equation, or you can say joint equilibrium equation. Although we have a theta, then we will use the joint equilibrium equation. So if you are using the joint equilibrium equations, if you are using the joint equilibrium equation, then you can able to find the theta value. You can determine the theta value here. If you know
Yes,
the
sir.
theta, you have found the theta value. Let us suppose theta comes out to be 5 radian. Just assume you have found the theta 5 radian. By knowing this theta value, is your structure is analyzed?
No, sir. Then we have to find the unknown moments and reaction forces.
Then for this analysis, you have to use equilibrium equations. Sigma phi equal to 0, sigma m z equal to 0.
We can also use this displacement equation at MAB equals to
Uh,
MFAB.
no need to use this slope deflection equation. You can simply use your equilibrium equations because you have find the unknowns that theta value. Now your structure is because you can use no. I'm saying no need to use, because if you use this slope deflection equation, then little bit complication. This complication is there. Simply use equilibrium equations. So my I want to say that If decay of the structure comes out to be 1, it means along with equilibrium equations, we require one more equations from which we can calculate this one unknown value. And that one unknown value, for the calculation of one unknown value, we can use the slope deflection method, we can use the moment distribution method, we can use any method. In that methods while solving, we have to use the moment equilibrium, we have to use the joint equilibrium equation or shear equation. We can find one unknowns using those methods. Now you have find those methods. Now you want to analyze the structure, so you have to use these equilibrium equations. Getting my point? What I want to say? Okay, tell me, in what situation you will use the moment equilibrium equation? In what situation you will use the shear equation? That depends on the unknowns.
Yes, sir. It
That
depends on
depends
the
on
degree
the
of. Yes, sir. It depends
that
on
depends
degree
on
of.
the unknowns. What type of unknowns or what type of degree of freedom we have. If you have a settlement, if you have a vertical displacement or horizontal displacement, for that analysis you will use the shear equation. If you have a theta unknown, that for that analysis you will use the moment equilibrium equations.
Yes.
Joint equilibrium equations you will use here, right?
Yes, sir. Yes, sir.
Okay, when we talk about moment distribution method, here we study or term stiffness of the joint. What do you mean by it?
Stiffness is basically the uh, rigidity per unit length. So
Stiffness is basically
rigidity per unit length. Rigidity per unit length.
rigidity,
Per unit
rigidity
length.
per unit length.
Or we can say it is the force required to cause unit displacement.
Unit displacement. Okay, or you can say the moment required to produce the unit rotation.
Yes. Yes.
So how will you determine the stiffness of the joint that connected the four members are connected at that joint?
So first of all, we have to find stiffness of all the members, all the four members, and the stiffness of the joint will be summation of the all the four members.
And how will you determine the stiffness of the one member?
It will depend on the support conditions, like the far end is fixed or far end is hinge or far end
If
is
the fire
fitted.
end is fixed,
Then it will be 4 EI by L.
4 EI by L. This is the stiffness 4 EI by L.
Yes.
Is this necessary that the joint must be rigid for finding out this stiffness of the joint? Maybe if the joint is if the joint is not rigid, let us suppose the joint is hinge. So will this stiffness or you can say distribution factor is valid there?
No, sir. If the joint is a hinge, then it will not be able to resist any moment. So in that case, in that case, it will not be able to hold. It will not be able to carry any stiffness. So joint has to be rigid.
Suppose that you have a prompt cantilever beam and that prompt cantilever beam subjected to hinge at the center point. Internal hinge is there, and I am applying the moment there at the hinge location. Is this possible to apply the moment at the hinge point?
So can you please repeat the question?
If any internal hinge is present in the probed cantilever beam and I am applying the hinge at that point, internal hinge I am applying at that point. Uh, Internal hinge is present and I am applying the moment at the internal hinge location. So
Okay, sir.
tell me, is it possible to apply the moment at the hinge point?
So if there is an internal hinge in a prompt cantilever beam, so it becomes determinate beam. In that case, if we apply a moment, no sir, because at hinge the bending moment should be zero from either side, so we will not be able to do moment at that point.
And also practically it is not possible, na? If you are applying the moment at that hinge point, so the members will rotate.
Yes sir.
If the members will rotate, the structure will not be stable.
Yes sir, because already it has become determinate, so if we further rotate it, it will become unstable.
That will be unstable. So I'm asking the is it possible? So only it is not possible. The structure will be unstable, and
Yes.
you are not going to analyze the unstable structure.
Yes sir.
Okay, how we determine the stability of the structure? How will you come to know that the structure given structure is stable or not, stable or unstable?
So if the ds of the structure comes out to be negative, it means it is unstable.
Okay.
And in addition to that, we also have to see about internal stability. Like if we don't have diagonal members in a truss, it will be unstable. So apart from external stability, we also have to check internal stability. I mean, we have to figure out that if there is sufficient movement of one member with respect to other member, then that structure will be unstable.
Yeah, right. What the difference between the unstable and mechanism?
So
What is the
unstable
difference?
means, yes, sir. The unstable means the structure will rotate or it will deflect significantly when a load is applied on that. But mechanism, it is a condition of failure when the stresses are exceeded beyond the yield stress. In that case, the failure will be gradual, and the reserve part of reserve strength of the material will be used, the strength which is beyond the elastic limit. So one is
So
to unstable means which can't
suppose
exist
that
infinity.
if in any structure mechanism has developed, can we say that structure is unstable?
Yes, sir. Once the mechanism has developed, then it will cause infinite rotation at the fixed moment. So this will make the member or the structure unstable.
So there at the mechanism condition, whenever the mechanism condition occurs, at that time, large deflections, as you told me, so you can say the appreciable movement will be observed when the mechanism has developed. So
Yes,
in
sir.
that way, we can say the structure is unstable. Right. Okay, let me give you feedback. You are explaining wonderfully. थोड़ा सा you have to concern about your statement. You are explaining answers like in this way. You should explain your answers in this way. You have told me very good. You have told me nicely everything what I asked you. Just complete your statements because if as my last question, why I asked you that what's the difference between unstability and mechanism? You have told me the difference in a beautiful way. You can club, or you can say in the last, you can say. So basically, sir, at the mechanism condition, we observe that there is appreciable movement of the one point with respect to the another. So we can say at that mechanism point, we can say the structure is unstable. You can add some more points to give more beautiful explanation about that point.
So
Getting
you
my
are
point?
telling
What
to
I
you are telling to summarize the answer in one line at last.
yeah you are yeah you can summarize the answers in one line. That yeah I want to tell you this.
Okay.
Clear? Everything is okay. Your concept is good.